Session is being recorded. Okay. The easiest thing to do is to actually move the cat and do part C first. Now remember, this is an orthonormal basis, u, v, and w, and x is x minus 2. I'm going to draw it. I'm just going to draw it. Easiest thing to do is move the cat. Exactly. Second easy. If only that was easy. The first thing I'm going to do is move the cat. The easiest thing to do is draw a picture. So you've got this orthonormal basis. I'm just going to draw, so given B, ON basis, that's important. ON, orthonormal basis B is this? Yes, it will be. But if you're from 1231 and you want to stick around and see some math, then you're welcome to do that. U, V, and W. U, V, W, and T maps from R3, transforms the space R3 given by T of X is X minus 2 X dot U, U, U. X dot U, U? Yep, X dot U, U. Cat, can you stop? No, cat. Ugh. This would be easier if I wasn't locked in here with the cat. Right. Yeah, question. This is question 10. I'm specifically doing C and D. But what I'm going to do first is draw what's happening here and move the cat. First thing I'm going to do is draw what's happening here. I have an orthonormal basis. I'm going to draw my orthonormal basis. V and W go out like this. You know what? I'm just going to draw it like this. It's an orthonormal basis. So it pretty much looks like the standard basis, although that's not necessarily the standard basis. And V going. I'm going to label them thus. This is U. This is my U axis. Here's my V axis. And here's my W axis. The vectors u, v, and w are going to be pointing, say, this way, and this way. They're unit vectors. They point in 3 different directions. They're all perpendicular to each other, and so on. Now, what is this transformation x? If you have some x over here, x dot u in the direction of u is this thing. This vector here, otherwise known as the projection. X dot u, u is the projection onto u of x. And I take my vector x and I subtract once the projection and I subtract it again, moving it over here to x. So if you like, not like that, what T does is reflect your x in the VW plane. This is Tx. It drops it down in the VW, in the plane. It reflects it in the plane spanned by V and W. So what was How is that the projection? That's the formula for the projection. Remember, the projection normally has the length of the vector in it, but these are orthonormal vectors, which means the length is 1. So it's a simplified version of the projection because the length is 1. You were told in the previous question that, in part C, that to note that V and W are eigenvectors with eigenvalue 1, which is a kind of hint at the fact that T doesn't actually do anything to those vectors. And for U gets reflected with eigenvalue -1. So here's this is T of U down here. So it reflects, it doesn't do anything to T and U and V, and reflects T of U down to here, which is negative U. That's U up here. So this is geometrically what's happening. Now let me go back to the questions. Share the screen. Orthonormal vectors are perpendicular and have unit length. That's what orthonormal means. Orthonormal means a little bit more than unit length. It means they are perpendicular to each other and have unit length. Okay, so let's go back here. Eigenvalue corresponding to U. Remember, U is the thing normal to the plane, and if you sub U in here, you get U minus 2U, which is equal to just minus U. So this is -1. The eigenvalue corresponding to V and U is equal to V and W is 1. Reflection by V and W. Okay. Now the nice thing, I'll give you a hint for higher year algebra. Every transformation has a happy basis, which makes the transformation particularly simple. For this transformation here, the basis is basis B. The transformation is particularly simple in basis B. If we go back to the picture, if you've got some, suppose you've got some vectors, what have I got in the question? Let me just check. -9, -6, and 8. So you've got some x, and with respect to the vectors, basis B, so x with respect to basis B, sorry, well, confusing myself now. XB, yeah, -9, -6, 8. Means this is equal to -9 times U, -6 times V, plus 8 times W. That's what it means in the standard basis. Okay. So let's keep the B around this, just so you know that this box refers to the coefficients of the a linear combination of the vectors from B in these proportions. And now it's in, and over here it's in standard. Okay. Now in terms of our picture, what does this look like? We've got the orthonormal basis. It goes -9U, so I'll draw -9 down that way. -6V, so it's going to go -6 this way, and 8 this way. So it's going to be, here's a -9. Here's the vector U. So it's -9U, so I'm going to go that much of this thing. Then my -6V, this is the V axis. Here's B going this way. B. I want -6 of those, so I'm going to go get -6 of them over here. Maybe over here to make it a bit more in proportion. -6. So I'm kind of here. This is -9u -6v, and then +8w. So this is my w axis. There's w, and I'm going to have +6 of those. Sorry, +8 of those. So maybe 8w. So I get that kind of. Sorry. Scroll down. About here. That's what I'm looking at. Here's my point, x. And I know there's chat messages. I'll just have a quick look at them. And now, what happens when I transform this thing? Well, remember, it's just going to reflect the. It's going to reflect it in this plane. So maybe I'll just do it a little bit more accurately. It's going to reflect it in this plane and plonk it up here somewhere. So my blue plane, the YZ plane looks like this kind of sheet, like this. Like that. Here's the kind of point of intersection. Those two are supposed to be equal. Here's Tx, like that. Now it's particularly easy to see what T does in this situation, because T applied to x in the basis B is equal to T of -9u -6v plus w. And all of these are eigenvectors. These two with eigenvalue 1, this one with eigenvalue -1. And because it's linear, it's -9t of u minus 6t of v plus 8t of w, which is, well, -9t of u, remember, is minus u, t of v is just v, t of 8 is t of w is just w. So this just ends up being 9u minus 6v plus 8w, like that. This works so nicely because we're using the happy basis B, the B that makes the transformation of T particularly simple. So in this case, the matrix, oh, sorry, you can't see what I'm doing. In this case, all that the matrix is doing is flipping the 9 to +9, and the -6 and the 8 stay the same. If I do the little check thingy, I hope I'm right. Yay. That's what it's doing. Okay. Were there more questions? I won't be doing the calculus part. Yeah, no troubles. Does anyone, while I'm here, does anyone want me to do the anything else in this one? Question 11. Why not? I'm already here, and I've got chocolate, and the cat stopped scratching me. So you play a branded tabletop game set in the far future, in the grim darkness of the 41st millennium. Your final turn, your opponent has to roll at least 26s on 200 standard dice. Estimate your chances of victory to 4 decimal places. Jeez. Okay. And here's a standard table of normal probabilities. How lovely of them to give that to you. Okay. So you have to roll at least 46s on 200 d6. This one's so hard. This is probably one of it's hard until you know what to do, and then it becomes easy. Allow me to enlighten you. So let's well, this one's And 12, okay, I'll do 11 and 12. 11's not so hard. So you can see what I'm writing. Let x be equal to number of sixes rolled from 200 dice. Then x has the binomial distribution, 200 experiments, probability of success 1/6. Now we want to know what is the probability of x is greater than or equal to 20. No, how many dice do I need to snatch victory? 40 out of 200. I need 40 sixes. So what is the probability that x is bigger than or equal to 40? Okay. Find. First step, draw a picture. Always a great idea. Picture. If you learn nothing else from me other than drawing a picture is a good idea, then I am totally fine with that. You can lead a rich and happy life having only learned that one thing from me. I'll be very happy. Come up to me in the street and say, Daniel, I remember I did your class years ago. You told me to draw a picture and that's all I remember. And I'll say, that's all you were supposed to remember. 40, 41, 42, ... 199. As you can imagine, the probability of rolling 200 sixes represented by the area of this rectangle is very, 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 very small. We want to sum up all of these things. This one here, this box represents the probability that x is equal to 40. This one here represents the probability that x is equal to 41, and so on. We want to find the area of the boxes. Now, it's a bit tricky because all the areas are really teeny tiny small. What we're instead going to do is appeal to the normal distribution, which is very similar to the binomial distribution. It kind of has a density function that looks a bit like this. Oh, about 10 minutes longer?
Okay, for coffee, we need to get my
Sounds great. Okay. So first we need to know which normal distribution. That means we need to let mu be equal to the expected value of x, which is just how many sixes you expect. That's 200 times 1 on 6, being 100 on 3. You expect this many sixes. And the variance, sigma squared, is 200 times 1 on 6 times 5 on 6, which is equal to, my brain's seizing up at this point, 250 on 9, I think. Yeah, maybe. Then x is approximately y, which is a normally distributed random variable with expected value 100 on 3 and variance 250 on 9. That tells us what the y variable looks like. And all we want to do is know the probability. Well, probability that x is greater than or equal to 40 is the probability that y, now remember y is a continuous random variable, this is its density function. We just need to integrate, not from 40, but from 39.5 in order to capture as much of these boxes as we could. You could integrate from 40, but your approximation wouldn't be as nice. You'd be losing half of this box here if you did that. Okay, so the probability that y is greater than or equal to 3.9 is something that we don't quite know given the information at hand. Meow, meow, meow. Meow. Oh, this cat is really clawing me today. You don't remember learning this? How can you not learn this? You must be, if you're in my class, you would have learned this. Okay. Now she's eating a screwdriver. Try doing it with a cat, clawing at you and eating your stuff. Okay, so this y is not normally. This is not the normal distribution at centered at 0 with variance 1. We need to adjust it so that it is normally distributed with variance 1. The first thing we're going to do is shift everything over a bit so its expected value is 0, and we do that by subtracting 100 on 3 from both sides. Move. So we're slowly transforming y away from this freaky normal distribution into the standard normal distribution. 39.5 minus 100 on 3. And so that centers it back, so its average is 0, or so its expected value is 0, and then we need to reshape it because it's too flat. And we do that by normalizing and dividing by the square root of the variance. So 100 on 3 divided by the square root of 250 on, so that's 5 on 3 root 10, greater than or equal to 39.5. I'm just going to do 39.5 minus 100 on 3 divided by 5 on 3 root 10 is equal to, calculator time, 39.5 equals that, divided by 5 times 3 divided by square root 10, 1.17. People's telling me stuff in chat. Yep, 1.17. We got the same answer. Yay, 1.17. Thank you. Now, the good news is, so here's my little calculation. The good news is this is equal to the probability that z is greater than or equal to 1.17, where z is the normal distribution, expected value 0, variance 1, because we made it have expected value 0 with this transformation, and we divided by that to make it have variance 1. And this is where you grab your table, and your table tells you and that big table tells you 1.17. That's going to be this one. Yep. 879. No, 8790. Yep. Now remember, the table actually tells you the probabilities the other way around. Z less than or equal to 1.17, which is 1 minus 0.8790. 8790? Yeah, 8790, which is 0.0121. Is that right? I think that's right. 121. Do you think that's right, Charlotte? Let's check it out. Hang on, I can hear myself. Chicken approves. Nice. Ow! Oh. The amount of times she scratched me. 0.121. She's on my lap now, but she's not scratching me, so that's okay. No, do not scratch my screen. That's not okay. This is not working out for me. Okay, how did I do? 121, not acceptable. Do I have to put the 0 in? Still not acceptable. Did I not do this correctly? 121. 1 minus 8790. Indeed. Okay. Did I not do the variance correctly? 200 my 6. $250 on 9. Square root is 5 on 3. Maybe I didn't do the calculation correct. Oh, hang on. My chance of victory. Oh, so it would be the 8790. Oh, in that case. $8790. No, still not right. Still wrong. Huh. 1.17. Here. 1.17. Okay, so Charlotte may be cute, but she just unplugged my Ethernet cable. It's not my favorite pet right now. She's throwing my Warhammer paints on the ground. Thanks, cat. Okay, so where were we? We were trying to figure out if they had forgotten. So this is the probability that
they roll 46s and snatch victory from me, estimate my chance of victory, which is the probability that they don't do that, which is pretty high. I'm saying it's this much. Now this is without the continue. Can you see what I'm doing? Hang on, what have I shared with you? You can't see what I'm doing. Sharing that one. How did I do? No, that's still not correct. I don't know what I've done wrong at this point, and it should be 3.95, and I don't know what's going wrong. Dividing by the square root of the variance. Square root of, so square root of, I'll just calculate it one more time. 3.95, 3.95 minus 100 divided by 3 is that. Okay. Hang on. That's not right. Oh, 39.5. Oh, 39.5 minus 100 divided by 3 is, yeah, that. Yep, that looks sensible. Divided by square root 250 on 9 equals 1.17. Yep. And the probability 1.17 is pretty close to 1.17. And then the probability should be 8790. 1.17, 8790. Like that's the answer as well. Okay, fine. What do you think the answer is, MapleTA? It won't tell me. Answers are provided. All right. That's the right method. I need to go. I'm not sure what's happened here. I'm going to find out what's going on. I only got 3%. Makes me feel bad. I will look into that question and see what's going on, because that's, as far as I'm concerned, that's the right, we got the right answer. And yeah, at this point I'm feeling 3%. At this point I'm feeling like I need to eat again. So the method is I can't explain it to you now. I can't. I'm doing my best just to sit here and keep it together with the cat. You didn't watch the lecture. Well, can I advise that you watch the lecture, please? All right, I'm gonna go. Good luck, everybody. There'll be consultation forms. General Kenobi, if you don't get the lecture, then come to my consultation hours and we'll have another go. Right, and the decryption of Babylonian tablets will not be on this exam. For that, join History of Mathematics next year. I'll see you guys later.